This lesson is about factoring polynomial expressions. The first thing we always look for when we factor any polynomial is for our greatest common factor, something that is common to every single term. In the first case, we have 3x plus 6. The greatest common factor here is a 3 because 3 will go into both 3 and 6. So the GCF is 3. What I'm going to do is you take out your greatest common factor. So my greatest common factor is a 3. When I take a 3 out of 3x, I'm left with an x. When I take 3 out of 6, I'm left with a 2. And the reason is because 3 times x would give me 3x, 3 times 2 would give me 6. So my factored form is 3 times x plus 2. For factoring using difference of two perfect squares, again, the first thing we look for is a GCF. Unfortunately, there is not a greatest common factor between x squared and negative 81. So what I do notice is that I have a squared factor minus a perfect square. A perfect square is a number where you can take something times itself to get to 81. In this case, what number multiplied by itself equals 81 is a 9. Therefore, my factored form, and you have done ones like this before, will be x plus 9 times x minus 9. And you can always check to see if you factored it correctly. X by foiling, like we did yesterday. X times x, if I were to check this, would give me x squared. X times negative 9 is negative 9x. 9 times x is positive 9x. 9 times negative 9 is negative 81. Now I can notice that the negative 9x and the plus 9x will end up being a 0. So you're left with x squared minus 81, which is what your original was. So when I have a difference of two perfect squares, I will factor to an x plus something or x minus something. For factoring quadratic trinomials, you have done a few of these before. We will get to more complicated ones in the near future. We have x squared minus 2x minus 8. What we are looking for are factors of negative 8, two numbers that multiply to negative 8 that will also add or subtract to a negative 2. So my factors of 8, if I were just thinking about it, would be 1 and 8, 2 and 4, and that's it. But I want two numbers that are going to add or subtract to a negative 2. The only one that's going to do that is the 2 and the 4. In order to add or subtract to a negative 2, I am going to need to have a positive 2 and a negative 4. So when I write as my factored form, it's going to be x plus 2 times x minus 4. And again, that goes up there, I just can't fit it. If I were to FOIL that, I would notice it does factor right to x squared minus 2x minus 8. Factor by grouping is brand new. The first thing you will still look for is a GCF into all four terms, and it's not. There's nothing there. Then you should notice that your highest power is to the third power, or cubed. When that is the case, and you cannot take out any more GCFs, you have to use factor by grouping. Actually, this was a 6-point question on the June 2013 Regents, so it's very important that you are able to do this type of factoring. So where it says GCF question mark, there is none, so I'm just going to write no. So factor by grouping next. What you do is you look at your first two terms, a cubed and a squared, and you look for a GCF in those pieces. The GCF there in that first half is an a squared. When I take out that a squared from the first two terms, I'd be left with a plus 1. Then I look for a GCF in the second two terms, negative 2a and negative 2. My GCF there is a negative 2. When I take my GCF out, I am left with an a plus 1. What you should notice is that your parentheses match up here and here. Okay? If they match up perfectly, you know you did factor by grouping correctly. What you can do if they match up is that you write the a plus 1 again, times you write what you have left. You should notice you have an a squared left in the first piece and a negative 2 left in the second piece. So it would be a squared minus 2. And that's the factored form. I'm going to do one more so you can see it. But again, we'll practice more of these tomorrow as well. On the one on the right-hand side here, I look for a GCF. There is not a GCF in all 4 terms, so I'm going to write no in there again. Then I do factor by grouping because my highest power is cubed. Now, with factor by grouping, my GCF in the first 2 terms is b squared. What I am left with when I take out the b squared from the first 2 terms is 5b minus 1. Now, in the second 2 terms, I don't see a GCF. And I do notice it looks similar to what I had just written in parentheses. The only difference is that it's off by a negative. Instead of being a positive 5b, it's a negative 5b. Instead of being a positive 1, it's a negative 1. So what I am going to do is I'm forced to either take out a 1 or a negative 1. I'm going to take out a negative 1 to force my parentheses to match up. When I take a negative 1 out of negative 5b, I'm left with 5b. When I take a negative 1 out of positive 1, I'm left with a negative 1. I do notice that my parentheses match up, so I'm going to rewrite it on the next line. And I am left with a b squared in the first term and a minus 1 in the second term. 5b minus 1 does not factor any further. However, b squared minus 1 is a difference of 2 perfect squares. And that will factor to a b plus 1 times b minus 1. And you'll get used to seeing these in the future and being able to figure out if you can go any further. For tomorrow, the questions you are going to ask yourself are going to be these. You're going to first look for a GCF. Then you're going to see, is it a difference of 2 perfect squares? Is it a trinomial that you can factor? Or are you going to have to use factor by grouping? And the rest we are going to do tomorrow.